Okay, so this video is going to go through the largest number of divisors written question. This one's probably the hardest one that we've done so far. And with the tools that we have, I can't even create it perfect. We'd have to use arrays, and I kind of explain that down here. But let's read what it does. It says, write a program called Largest Divisors. It prompts the user to enter an upper bound, a positive integer value, and lists the number with the most divisors. It is possible that multiple values have the same number of divisors. For example, if the user enters 10 for the upper bound value, the numbers with the most amount of divisors are 6, 8, and 10. And so 6 have factors of 1, 2, 3, and 6 in it. 8 has 1, 2, 4, and 8 in it. And 10 has 1, 2, 5, and 10 in it. Okay, so again, let's kind of go back. Let's use, I wonder if, let me see here. How much would 12 would have? 12 would have what? 1, 2, 3, 4, 6, and 12. So let's do let's do 12, and that will get us past only having 4 in here. We'll have actually 5 numbers. So let's just demonstrate that. We can test 10 as well if you want. So 12 has 1, 2, 3, 4, 6, and 12. So those are its factors. 1, 2, 3, 4, 5. I'm sorry, I thought it was 5. It's actually 6 numbers are a factor of 12. So when we do this, again, we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, and 12. And what we're going to do is we're going to create a tally for each one. So first time through, 1, that's going to have one factor in it. So that's going to be the largest number of factors for the very first one. But then when we jump to 2, 2 is going to have 2 would have 1 and 2 in it. And so this would now become again, we have to count these up, so it would be 1 and 2. So 2 is larger than 1. So this would be our largest number of divisors right now, okay? And then we get to 3. 3 has 1 and 3, so there's only 2 divisors in there. So since 1, 2 is not greater than 1, 2, the number 2 is still going to be your largest number of divisors. So see how it says in my explanation, it is possible that multiple values have the same number of divisors. I could fix that if I have an array, but I'm not using an array. So then we jump to 4, and 4 has 1, 2, and 4 as its divisors. So that's, you count that 1, 2, and 3. And so now 3 is greater than 2 right here, so this jumps to your largest. And so it would go so on and so forth until we get to this, and this would be our largest number. So we would have to print 12 would be the largest, has the largest number of divisors in it. Okay. So you know, go through, create your program like normal, import the java.util.scanner class. So I'll just say what my largest divisors equals new largest divisors. And I can say scanner, my scanner equals new scanner system.in, and I got to make sure, let me do this, I'll say int upper bound equals 0. So then while, this is just going to make sure that I enter an upper bound that's actually positive. So while upper bound is less than 0, so if the user's messing around and I just say system.out.println, let's see here, please enter an upper bound number. And so this would force them to enter a positive number. So upper bound is equal to my scanner.next int. And I'll just say my largest divisors dot set largest divisors, and I'll pass in the upper bound variable. So I'm actually going to copy this, and I did this wrong. I don't want this inside the method or inside the while loop. I want it outside that. So, and then it looks like there we go. Sorry, I'm being kind of a stickler and making sure that I got proper spacing. So then we go in here, we put in our set largest divisor method. So I'll say public void, and I'll pass in the upper bound. Upper bound is an int. So I can say int my upper bound, and I can then set my upper bound equal to upper bound. Alright, so this is where we get to our this is where we would get to our algorithm that we got to come up with. Alright, so this is where, 12, we have to have a loop that will run through all 12 of them. Okay, so we would say for, and we'll say int I equals 1, because we would start at 1, and I is less than or equal to my upper bound, because we're going to test all of them, I plus plus. Okay, so that will get us 1 through 12, right? Now we got to start splitting it up into each, if we're on the number 4, then we got to start 1, 2, 3, and 4. 3 doesn't work because 3 isn't a factor of 4, okay? So when we got to, if we did 5, 5 would be, well, 1 and 5. But you still need a test for 2, 3, and 4. Those aren't factors, but you still have to test for them. So we're going to use our modulus operator to figure this out, okay? So I have to use another for loop, and let's just call it x. X is 1, and we want to make sure x is less than or equal to I. So again, I is going to get us to whatever we're on here. Let's say we're on 8, and then we've got to go again on 8. 1, 2, 3, 4, 5, 6, 7, 8, and then since 3 and 5 and 6 and 7 are not multiples of 8, we would skip those, and we would do that using our algorithm with our modulus operator. So let's see here. X is less than or equal to I, so then we got to do x plus plus. Again, nice nested for loop. Definitely, this would be, again, I think you guys could program this, but writing it out from scratch is definitely another story. And this one adds new difficulty to it, because it's not just doing a nested for loop, but you have to create a counter that counts up each one. Okay, so again, this would be probably as hard as anything you would see on an AP test. Okay, so anyway, we get in here and we say if we do our modulus I modulus x. So 1 for the first one, 1 modulus 1, is that equal to 0? Yes, it is. So we do a num divisors plus plus. And so I need to define num divisors. So num divisors is equal to 0 at first, okay? It's always going to be equal to 0 at first. That's what it defaults to. But 1 modulus 1 would give us a remainder of 0. So then we add 1. So now I, which is 1, is now our new largest number of divisors. Okay? So let's do this. You know, then we get to 2. 1 and 2 are divisors. So I would become the upper bound for 12 would 12, but I would then become 2, right? So we would get back into here, and we start at 1. Is 2 modulus 1 0? Yep. So then x would be added up. Is 2 modulus 2 0? Yep. So now our largest divisor right here is now 2. So, you know, I is now the largest divisor, okay? So we would do this over and over again to figure out what our largest divisor is. Right here is where we've got to do our counter information. So if the num divisors let me think here if I'm doing something wrong here. I also need to do this too. We'll call it largest divisors, and that will also equal 0. Okay, and I'll show you why I did that real quick. So num divisors, if that is greater than or equal to the largest divisors, okay, we've got the largest divisors equal to the num divisors, and then we've got the divisor equal to I. So this actually gets kind of complicated. So what we'll do here then as well is say divisor equal to 0. This is actually, you got to keep a lot of things straight in your brain. And so let's do this. So we'll say system.out.println. Our divisor is basically I, and it says has the most number of divisors, period. Okay. Plus it has largest divisor plus divisors. Okay, so largest divisors. Okay. All right, so again, we get down here, and our upper bound is 12. We start at 1. X is 1, so 1 modulus 1 is 0. So then num divisors becomes 1. So if num divisors, which is 1, is greater than or equal to 0 at first, then largest divisors becomes 1, because num divisors is 1. And then your divisor, your divisor is 1, so that's I, so that's 1. So it would say 1 has the most number of divisors. It has 1 divisor, okay? Then what we got to do is we got to set this back to 0. So we'll say divisors, we'll set this back to 0, and then we can run this again, basically. So we come back up, I becomes 2, x gets set to 1 again. 1 is less than or equal to 2, so we've got 2 modulus 1 is 0, and then x becomes 2. 2 modulus 2 is 0. So this got added up twice, and now it's 2. Okay? Because remember, we set it to 0 each time, and so this becomes 2. 2 is now greater than 1. So now largest divisor is 2, and our divisor that is the largest is the number 2. So 2 has the most number of divisors. It has largest divisors. It has 2 divisors. So it will do this for every single one, and as long as it is this one's the largest, so it will say that 8 has the most number of divisors. It has 4 of them, and then it will say 10 because 10 has the most, which is basically equal to 8. It has 4. 10 has 4, just like 8 does. But finally, it will get to this, and it will say that this 12 has the largest number of divisors, and there's 6 of them. So I think this works. Let's try it. Hopefully I didn't make any mistakes. But if you're able to write this out and think this through by hand right now, you guys are in a really good spot. And if you're not, don't get too frustrated because this is actually pretty difficult. Okay, so 1 has the most number of divisors. Like I said, it has 1. 2 then has the most number of divisors. It has 2. 3 has the most number of divisors. It has 2. 4 has 3, 6 has 4, 8 has 4, 10 has 4, and 12 has the most with 6, and that's the last one. So go through and again think about how this is done. If you have to write the table out for this and write out every value for I, X, and num divisors, then you can kind of think through, then, you know, this is pretty easy. Because all this does, counts it all up, and now your old high gets switched out with the new largest. So your old largest gets switched out with the new largest right here, if it's greater than the old largest. And so then you want to figure out which one you're actually on, which would be like, you know, which one's the largest that you're currently on. So, you know, this is the largest first time through, then this is the largest. And then since these are equal, this is the largest, but then this becomes the largest, and then 8 becomes the largest, and then 10 becomes it, and then finally we end with 12. And I would need to do an array in order to just get one of these going. And I'm not going to do that right now because we're not there yet. So this should suffice. And then really get you thinking how to write this out. But this is kind of the last practice. This is the last practice written problem we have before quizzing. And this is by far the hardest one we've done so far. So take your time with this. You might have to go back and kind of study it a little bit. So this video is done. Let me close out of here.